Now we look at problem 7, and here we firstly find the graph of function f is here, and also we have two area functions of f. So we have the first area function is ax. We integrate from 0 to x of t when x is between 0 and 2. And for the area function b, we integrate from 2 to x of ft dt for x between 2 to 5. So we're going to, based on those two area functions and the graph of f, to evaluate several quantities. So firstly, we look at a2. That means basically we're going to plug 2 into the first area function, and we can see a2 is equal to integral from 0 to 2 of ft dt. Basically, for a2, it is the area of the region under the curve of f for x between 0 and 2. So if we look at the graph, it is the area of this triangle. And we can actually evaluate this quantity by using the formula of the area of a triangle. That is 1/2 times the base b, I will use small b here, and times the height h. And for this triangle here, we can see that the base is this part, that is 2, and the height is this part, which is 1. So the resulting area of this triangle is equal to 1. That also means a2 is equal to 1. Alright, for the second part, we want to evaluate b 4.5. Remember, for the area function b, we integrate from 2. So that means we're going to find this part of area until x equal to 4.5. That is this purple region. So basically we can see it is the area of a triangle, which is here, plus the area of a rectangle, which is here. Okay, and also because both of the two regions are below the x-axis, so we're going to have negative area. Alright, so to do this, we will have b 4.5 equal to 2 to the 4.5 of ft dt. And it is the area of the sum of area of a triangle and a rectangle. So for this triangle here, its base is this part, which is 2. Again, we're going to apply the area formula for the triangle. And the height is this part, which is -2. Okay, remember we're doing the region below the x-axis, so we're going to have negative area. And then plus the area of this triangle, and we can see the base is 4.5 minus 4 times the height. We have a negative height, and that is -2. And here actually we used the area for the rectangle, which is given by base times height. There's no 1/2 factor. Okay, so if we do the calculation, we will see it is -2 plus this part is equal to the -1, and we have b 4.5 is equal to -3. Then finally, to find a prime 1, we firstly find a prime. By using the fundamental theorem of calculus, we can see that a prime of x is just fx. So if we want to evaluate a prime 1, it is equivalent to evaluate f1. If we look at the graph, the function value of f when x is equal to 1, it is 1. So f1 equal to 1, that means a prime 1 is also 1. So this is the final result. Alright, then we go to the fourth part of this problem. So basically here we have the same setting, but we're going to evaluate the integral of fx dx from 0 to 4. So if we look at the graph, basically it is the area of this triangle above the x-axis plus the area of this triangle below the x-axis. So in some other way, we can rewrite this integral as a2 plus b4 by our definitions of the area function a and b. Okay? So for a2, we already find it in the first part, it is equal to 1. And for b4, which is the area of this triangle below the x-axis, well, actually it is part of the b of 4.5 we find in the second part. So it is by using the formula for the triangle, we have 1/2 times the base, which is 4 minus 2, times the height. Remember here we have a negative height, which is -2. So if we do the algebra, it is 1 plus 1/2 times 2 times -2, and the result is -1. So that means the integral of fx dx from 0 to 4 is equal to -1. Alright, this is the fourth part. And then for the fifth part, we want to evaluate this quantity. But we can actually do something before doing the calculation. We can use the linearity of the integral to rewrite this integral as 0 from 4 of 3 fx dx plus the integral of 0 to 4 of 5 dx. And then by applying one more time of the linearity, we have 3 times the integral of 0 to 4 of fx dx plus, for this second part, it is just the integral over a constant. It is equal to 4 times 5. Alright, now if we look at this part, this is exactly what we find in the fourth part. So we're going to plug in the numbers. That is 3 times -1 plus 4 times 5, that is 20. Okay, so if we do the algebra, the result is 17. Alright, this is the fifth part. Now we are going to look at the very last part of this problem. We're going to evaluate the integral of the absolute value of fx from 0 to 5. So firstly, we're going to find the graph of the absolute value of fx. So basically, if the graph is above the x-axis, we're going to keep it. But if it is not, we're going to flip above the x-axis. So that means we're going to keep this part and then reflect this part about the x-axis. That means we're going to have something like this. Okay? Alright, so we're going to evaluate this part of area. So everything here is positive. Alright, so we can actually split this area into 3 different pieces. The first part is this triangle, and maybe I didn't have a very accurate drawing here. I'm going to redraw it. So the second part is actually this triangle, and the third part is this rectangle here. Okay, so for this first triangle, its area is just what we find in the first part, that is A2, and it is equal to 1. And for the second part, for this triangle here, we can use the formula for the area of the triangle. It is equal to 1/2 times the base, that is 4 minus 2, which is 2, times height, and which is 2, because we're going to, how did we get this part? We just reflect the curve below the x-axis above to the positive part of the y-axis. So basically, this part and this part are equal. So the height is positive 2 now instead of negative 2. And then plus the area of this third part, which is a rectangle. Its base is 5 minus 4, which is 1, times height, which is 2. Okay? Alright, A2, it is equal to 1 plus 1/2 times 2 times 2 is 2, plus 1 times 2 is 2, and the final result is 5. So this is the final result of this part.